Okay, so if you finished basic movement 1 and basic movement 2, the next challenge is a Sensor1-Touch challenge. So under training in the RobotC Highrise Virtual World, select Sensors1-Touch and press play. Now, this is going to be using very similar code from our previous examples. We're going to need a grab block, lift block, lower block, release block, but now we also need to be able to detect our target using a touch sensor or a bumper sensor. So I've added some code here. We need some variables and we need some more functions. So you can open up your basic movement 2 or basic movement 1 and add these functions after you've saved it as Sensors1-Touch. Okay, here are the lines of code we need. Okay, we need to declare an integer variable called left motor encoder value, set it equal to 0. Do the same thing, integer right motor encoder value, set it equal to 0. What happens is we're going to be moving forward until we bump into our target, and then we want to be able to move backwards exactly the distance that we traveled forwards. So we're going to save that value, store it in these two variables so that we can use it for our backwards motion. Okay, so then we need a forward until bump function. So here we have forward until bump. It doesn't have any parameters or input values. And we're going to do a while loop. So the while loop is set up so that while get bumper value for bump switch, which is on the front of the robot, while that value is equal to 0, in other words, it hasn't touched something, set the motor speed for left motor and right motor to 75. So go forward. Now the bump switch is equal to 0 only when nothing is touching the bumper switch, when the robot. So make sure the arm is up when you're moving forward using forward until bump. It won't work if the arm is all the way down. Okay, so we do this while loop. It's going to go forward all the way until the bump switch is activated, and then it'll break the while loop and go on to the next line of code, which sets the motor speed for left and right motors to 0 and stores the encoder values for the left and right motors in our variables that we've created. So left motor encoder value equal to get motor encoder left motor, and right motor encoder value equal to get motor encoder right motor. We're going to use these values in our move backwards to start function. That's right here. So move backwards to start. See where the robot is starting here? We want to come back to that same position on our second run, or on our backwards motion rather, so that we can be in a precise location to move to the next block. So here with move backwards to start, again, there's no input values. We don't need them. We're going to call them here from our variables that we've created. Move backwards to start is going to reset the motor encoders for left and right motors to 0. And then move motor target for motor 1, we want the negative left motor encoder value. So we want to do the reverse of what we did before. And our speed I have here at negative 75. Move motor target motor 6, also a negative in front of right motor encoder value, because we want it to be going in reverse. And the speed is negative 75. Okay, so we should back up exactly the distance that we traveled forward and stop. And then wait until motor stop we need for the purposes of keeping the function going, but only until it's stopped both motors, and then we want to go to the next line of code. Okay, so here's an example of what you could be writing in terms of your function, the list of functions. We're going to go forward, grab a block, raise your arm up, continue forward until the bump switch is triggered, let go of the block, move backwards to where you started, and then in point turn right, you got to move to the next position where the green block is, point turn left, and then lower your arm to get ready for grabbing the next block. So let's see what this code does. Here we've moved forward, grabbing the block and raising the arm. Now we're going to continue forward until the bumper switch is triggered. Release the block. Oops, didn't go into the target. You're going to have to change some values to make that work better. But now we're to a number value. Now we've turned. Oh, that's not a very good turn. We have to change the values for that. Turn and set up for the next position. Well, we're not really in the right position here for this green block. So you'll need to change the values here. Looks like our point turn right and our move until distance aren't correct. Point turn left, lower arm, those are good. But they need to match up with what we need to do for grabbing the next block. So repeat this code each time for the green and red blocks, and you should be able to solve this. Now, the reason blue, green, and red value targets are, the target values are different. So I have to use a bumper sensor. I can't just use motor encoders to get to them. But it should work no matter what with our first blue block, because the blue, green, and red blocks themselves are always in the same starting position. Now, bump, release. If your code doesn't work once, feel free to try it a second time and see if you get better results. There are some things that happen that are unexpected. There we bumped and released it. Oops, the block still isn't going into the target. We're going to back up to the right starting position, exactly where we started before, and then we can set up for moving on to the green and red blocks. So you've got all the functions you need. Just got to make some changes here to get this set up right for the red and green block portions, and also, of course, get that block following into the target. Good luck!